Welcome back, everyone, to another Explainer. Today, we're diving into the fundamental rules that govern literally every single movement in our universe. We're talking about mass, force, and acceleration. But we aren't just stopping at the physics. We're actually going to explore how the source material takes these physical laws of interconnectedness and uses them to introduce a pretty surprising yet profound philosophical twist about education and how we choose to live our lives. So get comfortable, focus in, and let's get right into it.
Here is our roadmap for today. First, we'll cover the rules of motion. Then, we'll define force, mass, and acceleration and look at how those variables interact. From there, we'll explore some real-world physics applications. And finally, we'll shift gears to human connections, looking at teamwork, education, and peace.
Okay, let's jump right into Section 1, the rules of motion.
To really get a grip on these rules, let's ground this physics lesson in a struggle I think we've all faced at some point. Picture this. You're rearranging your living room, and you try to push this massive, heavy sofa across a thick carpet entirely by yourself. You're pushing with all your might, breaking a sweat, and the thing is barely inching forward. It's a massive struggle, right? But then a friend walks in, grabs the other end, and together you push. Suddenly, the sofa just glides across the room. So why does that happen? Why does that second scenario feel so fundamentally different? Well, the answer lies right in the core rules of motion.
Which brings us to Section 2, force, mass, and acceleration.
Those three components, force, mass, and acceleration, explain exactly why moving that sofa alone was so incredibly tough and why adding a friend completely changed the game. The big takeaway here boils down to one of the most famous equations in science, F equals ma. Force equals mass times acceleration. These three elements are inextricably linked. You literally cannot change one without impacting the others. Think of force as the push or pull, like you shoving the sofa. Mass is how much stuff is actually in an object, the heavy sofa itself. And acceleration is just how quickly that object speeds up or slows down. They're all bound together in this mathematical dance.
Moving on to Section 3, let's see exactly how these variables interact.
Let's break down the rules governing this relationship, because it perfectly maps out the math of our universe. First off, if you increase the force but the mass stays exactly the same, like two people pushing that same sofa instead of one, your acceleration increases. It moves faster. Pretty straightforward. But if the mass increases and your force stays the same, imagine trying to push a sofa that suddenly has three people sitting on it using the exact same push you used before. Your acceleration decreases. It slows down. And finally, if both force and mass change at the exact same time, well, it's kind of like a tug-of-war. You actually have to crunch the numbers to figure out which variable wins and what your final acceleration is going to be.
So, what does this look like out in the wild? Let's hit Section 4, real-world physics applications. Understanding these rules is so much more than just passing a science test. It's absolutely crucial for everyday safety and engineering. Engineers rely heavily on the F equals ma equation to design safe braking systems for cars. They have to calculate the mass of a heavy vehicle and figure out the exact force the brakes need to apply to bring that acceleration down to zero safely. And on a completely different scale, scientists use these exact same principles to plan efficient rocket launches. They're constantly calculating how much force, or thrust, is needed to accelerate a massive, heavy rocket right out of Earth's atmosphere.
It's super easy to see this in your own backyard too. Just picture two wheelbarrows side by side. One is completely loaded to the brim with heavy dirt, and the other is totally empty. If you give both of them the exact same push, meaning you're applying the exact same force, that heavier load is going to accelerate much slower, the lighter one will take off immediately. It really just takes the abstract math and makes it instantly real.
Or think about riding a bike uphill. Bicycle gears are a brilliant real-world hack we use to manage force. When you're fighting gravity on a steep incline, you need a ton of force to maintain your acceleration. But by shifting into a lower gear, the mechanics of the bike actually reduce the amount of physical force your legs have to apply with every single pedal stroke just to keep moving up that hill. You're literally manipulating the physics variables to your advantage.
So here's a question for you, pulled straight from the source curriculum. Based on everything we've talked about, why do race cars have these massive, high-powered engines, but are built out of the lightest materials possible, like carbon fiber? Just think about the equation. They are maximizing the force with the engine while minimizing the mass with that lightweight body. According to F equals ma, increasing force while decreasing mass gives you the maximum possible acceleration. It is quite literally the formula for pure speed. Now, let's pivot a bit. Section 5, teamwork and interconnectedness. Let's see how this builds into something a bit more profound. Here, the source curriculum actually shifts from literal physics to human relationships. The framework draws a direct parallel. Just like physical forces have to combine to move a massive object effectively, like our sofa example from earlier, the exact same principle applies to teamwork. The curriculum highlights this quote from Ecclesiastes to illustrate that interconnectedness is a fundamental law, not just of physical motion, but of human achievement. It frames this idea that pooling our forces together is what creates real momentum.
And that leads us right into our final area, Section 6, Education, Morality, and Peace. Here is the crucial point from the heroesmartacademy framework. It's how they intertwine biblical morality directly with education. They present a pretty stark reality. Education without morality will inevitably hurt. Think of raw intelligence in education as a massive amount of force. If that force is applied in the wrong direction, if it's not guided by a moral compass, it's going to cause damage. Within this specific framework, intelligence paired with bad choices doesn't lead to success, it leads to harm.
So the ultimate goal of this educational approach isn't just accumulating knowledge, it's finding inner stability. The curriculum draws on Romans chapter 8, which promises peace of mind to everyone who maintains a spiritual, morally grounded mindset. It presents the idea that when a powerful, highly educated mind is aligned with solid moral principles, the end result isn't chaos or destruction, it's profound peace.
I want to leave you with this final provocative thought to ponder today. What is the point of being incredibly smart and supposedly well-educated if you just continue to make bad choices that hurt yourself and the people around you? Just as physical acceleration relies entirely on the proper balance of force and mass, the curriculum suggests that a truly successful life relies on academic knowledge being firmly guided by a strong moral compass. Let that sink in as you go about the rest of your day. Thank you so much for exploring this with me, and keep your minds curious.